This is how to manipulate signals, make things sound the way you want them to sound. And I listed them and broke them down, all of the effects, into 3 different categories: dynamic-based processing, delay-based processing, and computer-based processing. Dynamic-based processing revolves around signals being louder and quieter in terms of a performance. Everybody knows that when a singer sings louder, it sounds different than when they sing quieter. When you play a piano quiet versus loud, it sounds different. So it's being able to manipulate the dynamics and the sound quality during that loudness to soft passage. Some drum hits will be louder than the other. Some guitar strums will be louder than others, and so on. So part of the whole process of making things sound polished and finished as a recording revolves around dynamic control. Let's say you've got 4 pieces in a band and they're playing. You go out to the club tonight and you watch a band play, and you notice that in the verse everybody gets quieter, and then in the chorus everybody gets louder and it gets bigger. It's not only that the drummer's playing more cymbals and it's filling out the spectrum more, it's also that they're playing harder. And if the musicians are well rehearsed and really know each other very well, they ebb and flow in terms of the dynamics. They ebb and flow together. And that keeps the perspective of the blend of the drums and the bass and the keyboards and the guitar all sort of intact as they move from section to section. Then the listener finds that the perspective of each sound element sort of stays intact as it moves along. Compressors can help a lot with that, and dynamic control can help a lot with that in terms of how loud and how quiet the dynamic of each element gets. Delay-based processing is processes where a delay is involved in creating the effect. We all know that when you stand on the edge of the Grand Canyon and you shout, "Hello!" you hear, "Hello, hello, hello." Delayed, coming back at you and getting quieter. That's delay, obviously, based upon the fact that sound takes time to travel, bounce off the other side of the Grand Canyon, bounce back to you, and back and forth and back and forth. That's an exaggerated version of what a delay process would be, but you can simulate that in your computer with a plug-in, a simple delay. Let me actually list a few other of the delayed processing effects. So delay is obviously one of those processes, and that's the longest of the delay processes. Before you could perceive a delay as being a delay, a specific repeat of what you heard. 50 milliseconds. That's quite short in regular terms, but in terms of the processing world, it's the longest. Now, if you make the delay shorter and we add it back to itself, we get phasing. So if you take a signal and delay it just slightly and add it back to itself that hasn't been delayed, then you get phasing. Well, that creates a notch in the spectrum where at certain frequencies they'll cancel each other out, and certain spots they'll add to each other. And so you create a distortion in the frequency domain of the sound, and it's a specific sound, especially if the delay changes just slightly. Then the notch of what you've created, the phasing, changes frequencies back and forth. That's called phasing. It's called flanging. Those kinds of effects are built off of shorter delays than just regular delay. So they're about between 1 and 10 milliseconds. 50 milliseconds so you can perceive a delay. 1 and 10 milliseconds or so for phasing and flanging. Even shorter delays create EQs. We discussed what an EQ is: taking a signal, delaying it just slightly, and adding it back in different proportions to its non-delayed self can either create a frequency where it diminishes or it adds at those frequencies. So EQs are delayed-based effects, phasing is, flanging is, delays are. Another one that we really haven't discussed very much, but it seems clear, that reverb would be delayed-based effects, because if you're in a gymnasium and you clap your hands and you hear the reverb, this whoosh sound that goes away, or you hit a snare drum or a kick drum in a big hall, that's based upon delays bouncing off walls at all different directions, all different times, arriving back at all different phases, all different times, and it's sort of a multitude of thousands upon thousands upon thousands of delays, all different, coming back to you at different times, and then eventually decaying to nothing. So reverb is a delayed-based effect. It wouldn't happen if there wasn't a delay because of the speed of sound, right? If the speed of sound was much faster, we wouldn't be able to hear any of those delays. Delay-based effects are the typical effects that people think of as manipulating sound. EQs, reverbs, delays that regenerate, phasing, flanging. The third category is computer-based effects. There's things like auto-tune, time correction of drums, where you can go into your screen and you can move a drum, nudge it here, nudge it there, and correct time. We couldn't do that when we were on tape very easily. It was very difficult to do. So computer-based effects are sort of the new world of effects that you can do with your computer and with sound. And there's a lot of different things that you can do in the computer that you could never do before, like correct pitch on vocals. Remember that these effects kind of put a date stamper on your music if you overuse things. When you use effects that are time delay based effects, like reverb, and those kinds of effects, those things have occurred since the beginning of time. We hear them in our everyday life. And so it tends to make the music sound more classic and not related to one time period. But when you use the newest computing device to generate the newest, coolest effect, that's when you get something that sort of stamps it as, oh, that's the era that was. So when you use effects, it's really wise to think about what your music really represents and whether you want it to sound classic in 10 years or not. Or maybe you don't. It just depends. If it's all about disposability right now, but cool, oh, this is cool, I'm going to use this because it's going to get attention. Or is it about the song and representing it in a way that generations from now, they'll listen to it and still understand it and it'll still be meaningful. Let's start with dynamic-based processing. Any process that alters the dynamic range of a signal. Compressors fall into that category. Limiters fall into that category. Expanders fall into that category. Gates fall into that category. And this is, as I said, one of my favorite topics because I truly believe that the most important process that you can have in making any musical project sound finished and polished is dynamic-based processing. Let's talk about compressors first. Compressors come in two overall categories. There's the feed-forward design and the feedback design. What a compressor really is it's a device that automatically controls volume. The feed-forward device looks at what's coming into the amplifier and controls the output of the amplifier. So it kind of knows how loud the signal's coming in and controls how loud it comes out. The feedback type design looks at what's coming out of the amplifier and says, oh, gee, it's getting too loud, we better turn down the input. So it's sort of a little behind the curve. And actually, you could consider a compressor to be called a leveling amplifier. In fact, some of the vintage compressors, like an LA2A, which is a vintage compressor, calls it a leveling amplifier because what it does is it maintains a consistent level of the signal. It sort of limits the dynamic range, and it's an amplifier. An amplifier, you typically think of an amplifier as something that takes something very small volume and makes it loud. This kind of an amplifier takes whatever's coming in and controls how loud and how quiet it gets, and controls the loudness.